Happy Monday again. So, not too much today. A couple things. Should go pretty well, I think. So, we've got to finish talking about dictionaries. I think we got through most of it, right, on Monday last week. And I missed you Wednesday, sorry. And then we'll also do midterm review, and we got to talk about project two, right? Okay, cool. So, which one do you want to do first? Project two? All right. Fire PyCharm here. Back to project two. So I did have one typo in here, I realized. Hopefully you found it here. Um, no, I'm sorry, that's right. This should be pretty good here. Okay, think we're good. That's changing it for a different thing, and it got ugly. So let's do a new project, project two. I got the date right on the due date, right, for this. Oh, shoot, open project. That's right, I already kind of started it, right? I give you some starter. I give you the gallows and the letters, yes, the word list. Okay, cool. So good. My other class, I had the due date wrong, and I had to honor that due date because I screwed it up. So if you didn't get it in on Wednesday, that's okay because we didn't go over it Wednesday. Hopefully, a little extra time was good for you if you needed it. Okay. Um, so we got the word list, and then we're just going to do this basically, right? So we'll should just be able to paste this in and add the rest of the functions, right? So let's do get random word, right? So here's the word list, right? So we can say get random word, define get random word. Here's the word list, right? Inside of the random word list, and then we're going to return my word list at index of random dot randint. I want 0, and I want up to, but not including the word list dot length of word list. I want that -1, right? Because randint includes that value, which just drives me crazy. So we got to make sure we import random, right? So we can just return a random one of those words out of this list here, right? That makes sense? And you could save it first and then return that string or however you want to do it. It should be okay. But just pick a random one out. Okay, so we get a random word, and then has the word been guessed? We can do this one next. We can define has the word been guessed given the hidden word and the letters guessed. So for this one here, right, my letters guessed is a list of letters. My hidden word is a string. There's a bunch of letters in it. So in English here, it's if I find a letter that has not been guessed, I know I've not guessed the word, right? So I can say for letter in hidden word, if letter is not in the letter guessed, I'm going to return false, right? If it's not there, you didn't guess it, obviously you haven't guessed the word yet. If I go through every letter in the hidden word and I haven't returned false, then I can return true. You have guessed it, right? Because I've looked at every word in the hidden word and I did not find it. Right? It's a little double negative there, but that hopefully that makes sense, right? So if we found every letter, we can return true. Yeah, the word's been guessed. Okay. And then has the person been hanged? This one's super fast here, given the number of incorrect guesses. Now, I think most of you probably did something like this. You said, hey, if my number of incorrect guesses does not equal 6, return true. You do it that way. Otherwise, return false, or else return false, or something like that. You did more work than you needed to, right? Because already here in your if statement, this itself is true or false. I can just return that, right? Because if it's not 6, I'm returning true. I'm sorry, if it's no, sorry. So if it equals 6, there we go. If it equals 6, I want to return true. Yes, they've been hanged. If it doesn't equal 6, I'm returning false. They've not been hanged yet. Right? That part follow? Statement has no effect. Sure. I don't know what that is. Okay, that's all right. Okay, so we got that one. And then display the hidden word. This is the tricky one here. Find display hidden word given the letters guessed in the hidden word. So we need to go for every word letter in the hidden word, and we're either going to print the letter or we're going to print a blank. Right? So we can say for letter in hidden word, if the letter is in the letters guessed, we're going to print the letter. And I want to change that ending character, right? I don't want them to go down the next line, I just want to put a space in here. If I didn't print the letter, then I can print an underscore character. I'm going to change my ending character to a space so I don't go down the line, right? I mean, it has no effect. What is... I'm super confused by this. I think it's just being upset with me. We'll figure it out. I don't know why I keep getting these yellow lines, right? So to display the hidden word, it's either the letter, if it's been guessed, or it's an underscore, right? Maybe. Okay. All right. To get a letter, given the letter's guessed, right? Because we want to make sure we don't get any repeats, and they're just giving me a single letter here. This is define get letter guessed. Okay. So I'm going to ask for a letter, or I can start with something that I know is in there. So that gets to be a little weird. So this one's a little tricky. So I might just ask for a letter first. So maybe we'll say that my guess is equal to an input of enter a letter. Right? We'll get a letter. Then I can say, how about while the length of guess does not equal 1, or my guess is in the letters guessed. If either one of these is true, I want to keep on asking. Right? Why is it so upset here? Right? And eventually I should get it is equal to 1, so this is false, and this has to be false. It's not been guessed yet. Right? Why? Yeah. Yeah, I could tell them an invalid guess. Print, or if, I don't know, we could do either check here. We could say, I don't know, if length of guess is not 1, print, please guess a single letter. And if it's not that, then it's got to be print already that letter. Or you already guessed that letter or something. I don't know. You already guessed that letter. And then ask for another letter. Sure. Um, why is it? I'm getting so many yellow lines. I don't know why it's giving me so many yellow lines. The word seems to have no effect for returning. What do you mean, no effect? Print has no effect. All right. Oh, we'll figure those out after. I don't know what it's doing here. And then when we're done, right, we can return the guess. Eventually, this loop will stop, and we can return the guess. All right, so we got that one, and then we need to print the gallows given a number of incorrect guesses. So this is a little bit long here, but that's okay. So given the number of incorrect guesses here. Now, really, we can just print this out, I guess. Let's say print gallows. So you do want to actually change how this is aligned. So those would have to stay over here for the raw string. So this gets a little weird here. So we can say, hey, if my number of incorrect guesses is equal to 0, then my gallows would equal something else, right? This would be the empty gallows. So there's no hanging man here, right? And then if my number of incorrect guesses is equal to 1, my gallows can equal the next thing, right? That's just the head. So this one was a little tedious here, but that's okay. If my number of incorrect guesses is equal to 2, then my gallows can equal the head and the body, right? And then if my number of incorrect guesses is equal to 3, set gallows. Oops. Goodness. So 3 is body and an arm. If number of incorrect guesses is equal to 4. Now both arms. If my number of incorrect guesses is equal to 5. And he gets one leg. Oops. And then just an else, I guess. We just set him to the full gallows. Right? Why not? And then we can print the gallows when we're done. So just wait. So depending on the number of body parts, right, we have a different string to print. Eventually we'll print the gallows out. That should be it. Let's give it a try. Yep. What did I do? Main? No interpreter. Sure. Didn't I make a new one? Didn't I make a new one? That's fine. Any of those should probably work. Let's try it. All right. So what letter should we guess? We've got 6 blanks. A. Oh, we missed. What should we guess? E? Uh-oh. Something's not right here. Are we... Oh, never added the letters guessed. Sorry. So I forgot to add it to letters guessed. So let me stop that here. So this, let me do the debugging process here because something seemed wrong. So if we were to debug this and not know off the top of the head what was wrong here, I'll go to display because it seems like, hey, display hidden words not working, right? We should have had another letter here, but we didn't, right? So let's put a breakpoint in here and display hidden word, and let's see what's happening in debug mode. What? Yeah, let's pick an interpreter. It's fine. All right, so I know what the hidden word is. Ooh, usually, that's a good one here. So I'm going to display the hidden word. We print out a bunch of underscores. Right, that's fine. And we have to get a guess. So what letter should we guess? A. Okay. Now, is guess not in the hidden word? That's not true. So we did not increase our number of gallows here. So we go here, and then we've not guessed the hidden word. Let's display the hidden word. So we got to step into our code for display hidden word. Now we're here. So now hidden word is still usually, and letters guessed is still blank. So I know the problem is I'm not adding the letter to the letters that I've guessed, right? So when I get a letter guessed, before I return guess, I want to take my letters guessed and I want to append the guess, right? Or when you give someone a list, it's mutable. You can change it. So before I return that guess here, I can add it to the list of letters guessed. Now this should actually be working here because I'm going to start tracking the letters that I've guessed here. Oh my goodness. Why? Stop that. Okay. Oh, it's a 4-letter word. What should we try? A? Oh, there was an A. And now we get A in the blank here. Look at that. Okay, what other letter? R? Nope. S? Nope. T? Nope. B? Nope. Let's try a B again. Well, we already guessed that letter. Let's try something long. Please guess a single letter. So the check seemed to work there. What other letter should we try? L? Nope. N? Nope. Oh, we didn't print what the word was at the end. So we should probably print that at the end, right? So at the end, while the word has not been guessed, we're done. We can print, or if the word has not been guessed, I guess, right? Or if the person's been hanged, we should tell them what the word is. Maybe if the person has been hanged, print the word was. Did I hit a word? I don't actually know what the word was. We didn't have it there. So let's try it again. All right, here's another 4-letter word. A. Oh, there's an A in this one. What else should we try? S. No S. F. No F. I. No I. L. No L. E. Oh, there's an E. What? D. Not a D. K. Nope. The word was race. It's a close one. Should we try it again? See if we can actually win. See if we can win one. Run. Run. Did I hit run? Run. I don't know what I did in this project. I'm sorry. That's fine. Oh, another 4-letter word. Should we try it again? See if we can win this time. E. There's an E. A. No A. R. C. Nope. N. Nope. S. Yeah, there's an S. What? T. Hey. Oh, we didn't print it out. Oops. All right, so maybe we should just print what the word was every time then? Just print it every time. That's probably even easier. All right, hang on. And then I copy pasted that. So number of correct guesses, print gallows, word by guess, get letter guess, plain a word, get random word. Right? So we did it. Oh, the game loops. We forgot that, but there's no points in the rubric for it. So if you didn't loop, then no biggie. You didn't lose any points because there weren't any points for it. My bad. Are you good? Want to try it again? More hangman? It's really hard when you get a three-letter word. Those are like impossible. And we didn't print the gallows when he fully got hanged either, did he? Did we? Oh no, we did. We did. But we didn't play when you won. That's okay. All right, so we commit that to GitHub. 1501. Here is Hangman. Oh, okay. How did that change? Okay, so I'm gonna. That didn't give me an environment. That's why that one changed. I'm not going to commit that one. I'm going to try this one here. And then revert, discard, pull, push. See if it runs now. No, why? Close, close project. Project 2. So run? Now it runs, of course. Like, I don't know what that was. I don't know how we changed that. We got to play one more time, though, right? One more time. A? No A. E. There's an E. I? There's an I. R? S? L? O? D? Hey! Nice. We only lost one body part. That's pretty good. Good guessing. All right. Cool. So we give that a close. Oh, I should have just closed the project. That's fine. All right. We got midterm review and then a little bit more with dictionary practice. What do you want to do next? All right. Let's go to files. Here's the sample midterm. It's just super exciting. So, first question. You acknowledge the academic integrity policy. There actually someone did a research study on this and published results, and we shared it around in academia because that's the sort of thing we do because we're really boring people. Uh, they tested whether or not if having the question at the end of the exam or the start of the exam made a difference. And it turns out people are more likely to lie if they had already cheated, and then you ask them if they did cheat or not. They're like, "Oh, I already cheated." I'll just say, "Yes, I didn't cheat." So if you ask them first, though, they're like, "Oh, okay, I'm going to agree not to cheat," and most of the time they didn't cheat. It's kind of cool. Like you put it in their head that they agree to not cheat, and then mostly people don't cheat. Like they're actually decent people. But if you don't ask them to the end and they already cheated, they're much less likely to admit to it because they don't want to get in trouble. And they don't want to go back and fix all the work. Like, oh, now I have to go and redo a bunch of crap. So we ask you first, and it's good. Another fun story about human behavior, just because it's interesting here. Are any of you fans of sports? Are you U of M fans? Because you go to U of M? Apparently, you could get free tickets as a freshman or something like that. That was a big perk. They were like super excited to offer that to people. I'm sure that made people come to Dearborn because they could get free tickets. Whatever. But so they did a study where they brought people into a room and they gave them a test and they said, okay, score yourself and you go up to the front and you tell them how many you got right on it and you got that many dollars essentially. So after about 3 minutes, it was like a big math test with a bunch of like long problems. Someone walked up and said, I got 15 out of 15 right, and they handed them 15 bucks. And someone else did it and got 15 bucks. Someone else did it and got 15 bucks. So they saw people they knew must have been cheating. So then people will be like, okay, and they just walked up and said, I got 15 out of 15, they got 15 bucks. So if they see other people cheating, you're more likely to cheat. And then they repeated the study and they brought a bunch of probably U of M students in, and they had people in U of M swag and they had people in Ohio State swag. And they had the people wearing the Ohio State swag go up and cheat and say, okay, I got 15 out of 15 right after a few minutes. And it turns out if you despise Ohio State and you see them cheat, you are less likely to cheat because you're like, oh, Ohio State's the dirty cheaters. We're better than they are. And it reduced the amount of cheating, even though you saw that they cheated and they got $15 for free, because you associate that group with dirty Ohio State fans, you wouldn't cheat because you wanted to be better than them. Super interesting human behavior stuff. So you all agree not to cheat. At the beginning, you all see each other agree not to cheat here, and no one cheats. And life is good. Okay, so please don't cheat because this way I can keep giving exams and you can take them at your leisure and you don't have to sit and I don't have to sit and watch you take a test. So that's super dull. So Wednesday, 12:30 p.m., the test will open. You have until next Monday, 12:30 p.m. to take it. Right? As long as you get it in by that time, you're fine. It is timed though, so you have the same hour 15 minutes, right? No matter what. So if you like taking tests at night, take them at night. If you like taking tests in the morning because you're a weird person, take them in the morning. Go for it. If you want to take it tomorrow at 12:30 p.m., go for it because then you've got time set aside. Yeah.
Or the school time for itself.
In Canvas, it's timed. So Canvas will have a little timer there and tell you when you got to submit. Yep. So take your time. It's 15 quiz style questions, like short answer questions, like true, false, and we'll look at some of those examples here, and then 3 coding questions. Okay. So as we go through, if you think you're an hour 15, for the 15 quiz questions, take like a minute per question or so, leaves you an hour to do the 3 coding questions. So if it takes you a little longer, that's okay, but you don't want to be taking like 5 minutes per question on the quick ones because then you'll run out of time pretty quick. Okay. So something like, oh, that was I had imported quiz questions from the syllabus quiz by mistake, so that was a dumb freebie. This one here. Blank is the command used to get input from the console and save the input to a variable.
Right.
Input. Yeah, input. There you go. So that's a fill in the blank. That one's pretty quick. Given the following variable, write Python code using the index notation to print each letter of your name. Here's alphabet. Something like this would print Eric, but with your name. So print alphabet index of this, alphabet index of this, alphabet index of this for your name. So probably about a minute here. I mean, counting might take a little long if you got a long name, but pretty straightforward on this one. Like we've done indexes of strings. Okay. True or false? If the answer is false, I like these kind of true false questions because they seem a little easy, but they're more like fill in the blank. So if it's false, you have to correct the statement to make it true. So a function may only return a single object or value.
True.
This one is true, right? Because you can technically return more than one thing, but that's a single object. A tuple is one thing. Even though the tuple contains a bunch of things, you've returned one thing. Right? So Python, even though it looks like we return more than one, will automatically pack it into a tuple for us. So it only ever returns one thing, even if that one thing is a container. So yes, this is true.
Like true. One false.
Yeah, yep, you just type true. So you wouldn't type false, you would correct the statement. So if it's false, you'd have to correct the statement. So if it said Python a function can return as many variables as you want, you could say false or give me this can only return a single thing. So true or false. You can use either a while loop or a for loop. They're interchangeable. And if it's false, correct the statement.
Or
So what would you do to make it a correct statement?
I will say there are specific locations for one would be better than the other.
Okay, sure. Or you might say you can always replace a for loop with a while loop, but you can't always replace a while loop with a for loop.
Yeah.
Yeah, so your answer was great too, and that works. But yeah, so that would be you have to give me the correct statement. Right? They're not interchangeable. Right? Some are better for certain things than others. Right? Um, True or false? Variable names are chosen by the programmer and can be any combination of letters, numbers, and the underscore character.
Well,
It's technically false because why? What's the true statement here?
we're actually read a program and we got to set a combination of letters and numbers for letters because there are keyboard.
Okay, but so they are chosen by programmer, not program, right? So that was the first part. Yep, and then you can't use reserved words, and you can't start with numbers. So a
Yeah.
bunch of wrong things about this one here. If you didn't change all 3 of them, I don't care too much. That's okay. As long as you're getting the main one, I'm good. A lot of people, I typoed this program versus programmer, and people didn't notice that I said program, and I decided that was too mean. So I just gave them points for it. Because they're probably assumed I meant programmer and I typoed it because that's a weird thing. Sure, that's fine. But yeah, can't be the reserved words, can't start with numbers, those sorts of things, with kind of what we're looking for. Right? Rewrite the bolded statement without the compound or combined assignment operator. Score plus equals 5. How do we rewrite this?
Or the score was fine.
Yeah, score equals score plus 5. So it's like a one-liner, right? It's a quick quiz style question. What 3 steps must you do when working with files?
Or
So we didn't get there. That's okay. So we didn't get to files yet. It won't be on the midterm. This is
so we just skip that.
well, this one won't be on your midterm.
Only.
No.
Oh, okay.
Yeah, so this was like just an example of a midterm I had given. So sometimes they fall different weeks. If I take a vacation, I give a midterm that week. um, so we're not traveling anywhere this fall. So it was later in fall last year. So that was all.
Why was it? Where did we start?
Open, read or write, and close. Yep. Yeah, we'll get to that. I think is that 2 weeks now, right? Or next week? I gotta look and see. No, a couple weeks till we get to files. Shoot, couple weeks. All right. Um, True or false? Functions can be made to accept parameters or arguments, which can be used in the code block of the function.
I'm false.
And why do you think it's false?
When you make use parameters, which will be passed that arguments and one.
Okay, you're being very specific with your language. I love it. I would have taken true, but the or meant like, do you want to call it a parameter or an argument? But yeah, so it is a parameter. You pass them as arguments, so that's very specifically true. I was not going to be that picky.
Let's make sure.
Yep. And then again, I copied out of the quiz test bank, so that was a bad one there. Repeat. Right. A while loop is guaranteed to run at least one time. True or false?
Oh,
False. So what's the correct statement?
there's the while run its combination is
Yep. So it might run 0 times, might run a bunch. Right. It runs if the condition's true. Right. True or false? Curly braces are used to create Python tuples.
well,
False. So what's the correct statement?
regular parentheses state by
Yeah. Parentheses or curly braces are used to make dictionaries. Either way would make it true. Now, you might be tempted, and I would prefer you not, to just put the word not in here. You could say curly braces are not used to create a Python tuple. That's technically correct.
Yeah.
But I like that you're giving me an actual true statement and not just adding the word not here. So let's try not to do that. Okay. I had someone do it on a quiz. I was like, all right, I got to give you the points because I didn't tell you not to. But yeah, I used the syllabus quiz. I did bad on that. All right. What will the value of result be? Bob's age is 20. Joe's age is 25. Mary's age is 30. Joe's age is greater than Bob's age. I copied this out of C++ instead of Python, so that should be and. The ampersands are and. So Joe's age is greater than Bob's age. Joe's is greater than Bob's is true. Bob's age is less than Mary's. True. Mary's age is less than Joe's age. That's false. So true and false means the whole thing is false. Perfect. All right. So now the 3 coding questions. Relatively short. The idea is you can tackle them in about 10 minutes or so that if you need 20, you can do all 3 questions in an hour and still have 15 minutes for the other question. So I expect this to take maybe 10 minutes or so. I can do this, again, just the way I sort of measure these things. It takes me like 3 minutes to do this. So triple that for you to be 10, and then maybe even double it if you need even more time. Just that makes sense in my head. I don't know. So write a function, prime factorial plus odds minus evens, n as an argument, that accepts an integer value for n. Keep a running result starting with 1. Then for each number from 2 to n, if the number is prime, multiply the result by it. If it's odd, add it to the result, and if it's even, subtract it from the result. It's just nonsense. I had to come up with nonsense so you can't Google it, essentially. Right? It's yeah. So n is the argument you give the function. So let's open up PyCharm here and take a look at this. I think I can't even copy paste. That's fine. So we'll do a new project. Call this midterm review. So we call it prime factorial plus odds minus evens. Sure. This when I Google things online or like Course Hero or Chegg, these kind of questions that I write that sound really stupid come up really fast because they sound really stupid. Like it's a very unique sounding word, so they're very easy to Google. It's sort of why they look like garbage. That's all. So prime factorial plus odds minus evens, right? That sort of thing. Given n. All right, so we're going to have our total starts at 1, right? And then for number in range 2 to n plus 1, because we want to go all the way including n, right? From each number 2 to n. So make sure we include n as the number. If the number is prime, multiply it by the result. So we have to find out if the number is prime or not. That part was not interesting. I said, go use this is prime function. We had done a prime thing before. Or if you just wanted to Google Python prime number checker, check function. I can't spell function, but it gave me one here. So this is not even going to do exactly what we want here, but it's going to be close, right? So we're going to add another function, is prime, given n, and we'll call it num, right? Because that way it matches the rest of the code here. So instead of printing is not prime, we're going to return false. We don't need a break. And then if it is a prime number, we can return true, else return false. This wasn't even the easiest one to go find here, but that's okay. And we'll say, hey, we got it from this website here. Right? I'm sorry?
What is this? Like, what we're supposed to do?
What is this one supposed to do?
Yeah, like, what,
Just this is prime part?
you know?
So it will tell me if the number is prime or not. I'm going to tell you true or false based on you give me a number.
Oh,
So if you give me a number greater than 1, I can check for it. If it's not greater than 1, I'm going to tell you false because 1's not prime, and anything 0 or less we don't consider prime either because they're negative, and sure, math people told me so. So if it's at least 2, then I'm going to go for I in range 2 up to half the number. Technically, you can be fast in this. You can take the square root of the number, round it up. So other solutions have the square root because that's faster. You won't find a factor bigger than the square root if you haven't found one that's smaller. That's okay. It doesn't matter. So the integer version of that number divided by 2, sure, why not? Or just do integer division. I don't know why they did that, but that's fine. Right? If it's evenly divisible, we return false. We found a factor. If we've gone through all of those numbers, we haven't found it yet, we can return true. We didn't find a factor. Okay, and there's a couple other ones, right? You can find a bunch of ones out here, right? Programis.org. That sounds real legit. Yeah, this one is the prime number version here, and this one's a little better, right? I like this one. We'll take theirs instead. And we'll use this one because I didn't have to change anything. Right, so sometimes like searching stuff online means it's a lot of work because it's not exactly what you want it to be every time. Goodness gracious, what am I doing here? There we go. We'll just steal that one, right? So if it's less than 2, it's false. And then we can start checking in the range of the square root plus 1 as an integer, right? Check if it's divisible or not. Now, the other thing they're not doing, though, here is a little silly. You can add another shortcut if you like, because why not add shortcuts? We love shortcuts here. We can say, hey, if n is equal to 2, return true, because 2 is prime. And then we can start with 3, and we can step every other, because I can skip all the evens. Right? If 2 wasn't a factor, oh, I'm sorry, I got to check one last time. So if n mod 2 is equal to 0, return true. So this looks a little longer here, but we're going to check, is it even first? Then I can check all the odd factors after that and have to not do a bunch of work, right? Because if it wasn't divisible by 2, it's not divisible by 4. If it wasn't divisible by 2, it's not divisible by 6, and on and on and on. So that's just some dumb shortcuts. And again, not important. This is just a fun fact for you. All right, so anyway, so if is prime, the number, I'm going to take my total times equals the number if it's prime, right? We said multiply the result by it. If it's odd, add it to the result. So then if number mod 2, now this is where we get that Python is truthy here, right? This means it's odd because anything other than 0 is true. So if I get 0 back, if there's no remainder, it's even, that would be false. So I'm going to take my total plus equals the number. Otherwise, I'll take my total minus equals the number. Right, subtract the even. Right. I took a little bit long with this is prime function. I'm sorry. I gave it to people. So if I didn't have to write that, this was 2 minutes. And again, sort of that idea, triple what it would take me, and then possibly even double that. Right? And then when we're done, we return total. That's the prime factorial plus odd minus evens for an n. I have no idea what it just comes up with garbage numbers, and that's fine. It doesn't matter. Right? It's just we wrote a function that did something, right? That makes sense? So here's a question, write a function that does something. Okay. Here's another one. Write a function bad hash of some string that returns the sum of all character ordinal values. And then write a function verify bad hash given some string and some hash value that returns true if the bad hash of some string equals the some hash value or false otherwise. So the sum of all character ordinal values. So bad hash. Define bad hash given, what do we say? Some string? Some string. It returns the total of all ordinal values. So total equals 0. And for letter in some string, to take total plus equal to the ordinal of that letter. So return the total. That's the bad hash. Right? Just returns the sum of all the ordinal values of the letters. Then the harder one, right, was verify bad hash given some string and some bad hash. Right? Returns true if the bad hash of some string equals some hash value. Oh, some hash value. Sorry, some hash value. Some hash value. Right? Otherwise false. So again, you could do this shorter, but if you'd like to be lazy, we can return my bad hash of some string equals some hash value. Right? Get the bad hash again, see if it matches.
So I wonder that never find that something
Some string, when I call the function, I'll give it some string. So I might, in my rest of my code here, I might say, my name is Eric, and then I can call bad hash of name. Right? So here's my hash value. I'm sorry? It's whatever string you want to give it, right? Functions take arguments. Whatever argument you give it, the function has to work with. So we're not asking the user for input here. We're just writing the function, right? And then print verified. I can't spell verified, right? And then we'll verify the bad hash given name and the hash value, right? So this would call the function verified. There it goes. I love spell check in my IDE. That's so nice. So whatever string I want to give it, it's going to work with. Right? So those are two functions for bad hash and verify bad hash. Right? The last one. Write a function vowel count sometimes y given some word that returns the count of all the vowels in the some word string. And because y is sometimes a vowel, generate a random value 1 to 10 every time there's a y. If the value is odd, count the y as a vowel. Be sure to account for upper and lowercase letters. So we're going to count how many vowels are in letters. Okay, so define vowel count given some word, right, or something like that. Yeah, some word, sure. Vowel count sometimes y, times y, given some word. So let's go through all the letters. Okay, so for letter in some word, oh, I also need a count here, right? So my vowel count equals 0 to start. Okay. If this letter is a vowel, let's count it. So if my letter is in, how about we just give it A, E, I, O, and U, and then A, E, I, O, U? That's one way. We can also take the letter and lowercase it, right? We could take the lower of the letter and just look at upper, or just take the upper of the letter, right? Is it upper? Upper? The letter? No, shoot. What is it? Letter 2 upper? It's just upper, right? I think it's just upper. I can never remember these things. That's okay. Right? So is the uppercase letter in A, E, I, O, U? That's a vowel. We'll take our vowel count plus 1. If it's not that, else if the letter is equal to, or letter.upper is equal to a y, sure, we could do that. Or maybe we say some word is equal to some word.upper. How about that? That way I don't have to do upper twice. Right? I don't want to do the same thing more than once. If it equals a y, then we have to sometimes count it. So we'll pick a random letter. So if my random.randint 1 to 10, mod 2, if it's odd, oh, we got to import random, sorry. Import random. Okay. If it's odd, count it. So again, if mod 2, right, means it's true because it's not 0, then I'll take my vowel count plus 1. when I'm done, right, with every letter, I'll return the vowel count, right? So let's try it here. We'll try print vowel count, sometimes y of, well, let's give it a string. How about like happy Monday? Okay. And let's do this a couple times, right? Because we know the y's should be randomly counted. So for, I don't know, iteration in range, how about 10? Iteration, we'll print the vowel count of happy Monday, right? So we know it should be at least 1, 2, 3, sometimes 4, sometimes 5, right? So let's give it a try. So 4, 4, 4, 5, 5, 4, 3, 4, 4, 3. It's pretty good, right? So there's a 25% chance they will get a 3, right? A 50% chance. Oh no. Yeah, 25% chance we'll get a 3, 25% chance we'll get a 5, and a 50% chance we get a 4, right? Because we get a 50-50 chance that the y is counted. So on the 50% and 50% that it is counted twice, and 50% and 50% that is counted neither time, and the remainder is it was counted at least once. You guys take stats, right? You're looking at me like I'm crazy. That was like easy. That's not even stats, right? Okay. All right. I'm not crazy. So I think that checked out, right? Out of the 10 times, it's about what we expected. Pretty close. So I feel pretty good. It did what it's supposed to do. The bad hash was verified. Feel pretty good about that. And then our is prime or the prime factorial of odd minus evens. We got to check that one too, right? If you're going to write your code, you might as well test it, right? You want to test your code, right? So how about like 5? Because I think I could do 5 by hand here. So 5 should give me from 2 to 5, right? So starting at 1, from 2 to 5, 2 is prime, so we're going to multiply it. So we get 1 total to becomes 2, but then it's even, so we subtract it, we get 0. Uh-oh. All right, so now 3. 3 is prime, so we multiply 0 times 3 is 0. It's odd, so we add it. Now we're at 3. Now 4. 4 is not prime, so we don't multiply, but it's odd, or it's even, so we subtract it. Now we're at -1. Now 5. 5 is prime, so we multiply, we get -5, and then we add 5, because it's odd, we get 0. So we should get 0 back out, right? For this one? It's a terrible function. Oh, we got 45. Did I do it wrong? My head? What did I do wrong here? How did I get 45? Okay, let's put a breakpoint in. We can do this, and we'll run in the debug mode. All right, so we gave n is 5. Total starts as 1, so let's step. So from 2 to n plus 1, this should give me 5. 2 is prime, so we multiply. Now total's 2. It's even, so we subtract. Now total 0. Now number's 3. Is prime. It's prime, so 3 times 0 is still 0. It's odd, so we add it. Now we're at +3. Did I not add right? I must not have added right. So +3. So 4 is not prime. Uh-oh. How did 4 return true? Oh, false. Oh my goodness. My function's bad. I optimized my function and did a bad thing. See, this is why we check our code. I did a bad thing. Now we got 0. Okay. You see what happened there? Even numbers are not prime. I was saying they were prime. That's what I get for trying to make this function better. All right, so we got 0 back out. But we can even try it for a bunch of numbers, right? So for value in range, how about we go from 1 to 10? We'll print value. Now, what do you think we're going to get here based on that sequence? One, 0, 3, -1, 0, -6, -35. So they stay pretty negative, it looks like, right? Because we start subtracting bigger numbers. That's fun. You okay so far in the midterm? All right, so an hour 15 or so to do it. Does that sound reasonable? Okay. So if you get stuck, something is better than nothing. because I can give you partial points for something. I can't give partial points for nothing. I think that makes sense. But I've had people take 20 minutes on a midterm and turn it in with none of the coding questions answered. Like they didn't even try to give me anything. So I can't give partial points. So at least try. Like just get something down. Like write the function. If you've got the function defined, I can at least give you a point for defining a function, even if it does squat. Yeah.
The thing is, honestly, I can barely understand the question. Yeah, it's like it's like over and over and
Okay. So they're going to sound like gibberish because they're just do something with numbers, do something with characters, do something with letter, like so that they're unique. That's the whole point there. If the steps don't make sense, let me know. Like, just send me a message, text me, call me. Like, I'll talk you through that part. Right? Whatever time you're taking it, just call me. That's fine. Um, that's not okay.
yeah.
Okay. Um, yeah, because the steps part shouldn't be the hard part. Like, it's is nonsense because they're nonsense. That's all. So it probably doesn't make a lot of sense because they're just weird. That's all.
But actually resolving them is seems to be simple.
Yeah.
But I just understand what the question was to
Okay. Yeah, and that's what you get when I take stuff out of my head and put it in paper. It gets really weird. Uh, so that's all. So let's can I let me download this one here? I want to copy paste. I want to see if our GPT can solve this one here or not. It wasn't able to solve one of my other questions, and I thought it was really funny that I couldn't solve it. The encrypt function, right? Didn't we try encrypt and it didn't work? Right? Let's see. Why can't I copy? Oh, goodness. I don't want to have to rewrite that. I'm lazy. All right, hang on. Let's do this. Right, make function vowel out. Sometimes y, some word, that return the vowel out or the count. It's the PDF. It doesn't. It's like it's an image instead of words, so I can't. Oh, okay. Here we go. Here we go. Oh, I think I can do this and extract words. Right? Where's my screen snip tool? OneNote. This is faster, right? Accept the terms. Sure. Come on. Come on. Supposed to be faster. OneNote. Add a page. I don't want that. Here we go. There's an extract text option here. Copy text from picture. There we go. See if that did it. Hey, it did. Let's see if it can do it. Okay, so it did all the vowels. Why it didn't do it as a single string, I don't know, but sure. Okay, count. Yeah, seems to work. So this one solved it. So please don't plug it into ChatGPT and then tell me ChatGPT solved it, because the English paper rules, you didn't do any work, right? If you want to solve it first and then ask ChatGPT if you did it right, go for it. Check yourself. Have fun. But like, don't copy paste this in. Is that fair? Okay. Yeah, so these ones I think it can do. It couldn't do our encrypt, so sometimes it's great, and other times it just completely falls flat. I wonder about the other one, the is prime here. So we do this one. Little function, copy text from picture. Let's try this one here. Now I'm really curious. And I like that it knew it was Python. Like, I think based on the naming convention, it went for Python and didn't give us some other language. Okay, so is prime. Okay. Interesting it did the 2 here, but sure. Number range 2, n plus 1, if prime, multiply. If it's even, subtract. If it's odd, yeah, okay. Does it seem to work? Even guess a test? Let's see, what does it give us here? What is the value of, let's give it 5. Think it'll figure out the right value? These tools are fun. You suck. No, sorry. It amuses me when AI gets it wrong because everyone thinks AI is so amazing. But us people who know how to program are like, yeah, it's cool. It's a good toy. So, sure. 2 and 5 gives us 10? What? And then odd number 3 and 5 it adds? There's no even number other than the prime number 2? What do you mean there's no even number? What happened to 4? Like, I I don't even know. Because I think this is right. Isn't this what we did? So it just completely went off the rails here.
Who would say that a shooting was the only even prime number?
No other number than 2. Okay. So it like embedded that if it is prime, then do these things. If it's not prime, skip it. Sounds like. But still, this is the wrong sequence. You don't multiply the primes first and then odd. And 3 is prime. Like what? So again, ChatGPT is a prose machine. Its job is to imitate things that it's seen before. It will imitate its heart out. And we talked about like, do you have the expertise to know if it's screwed up or not? That's what we're learning. Like that's hopefully the goal. We're writing Python code's fun and all. What we're learning to do is solve problems. That's the hard part of programming. Take a hard problem, break it down into steps simple enough a stupid computer can solve it. Because even these really smart computers can't solve the stupid problem sometimes. And if they get it wrong and we just copy paste it in and turn it in, or use it in a program that has impacts in real life, we've done a bad thing, right? But that's the expertise we're building. It's how we solve problems, how we break things down step by step by step, how you use the debugger and see what's happening, see where we screwed up, right? I've been doing it for almost 20 years now, so some of it's faster. Ideally, you get experience as you go, right? And like a mechanic who's been a mechanic for 20 years can hear a noise in a car and be like, oh yeah, it's this thing. I hear a noise in my car and I say, crap, here's more money I have to spend because I have no idea what's wrong with it, right? I don't have that expertise. That's what we're building, right? So I don't know. Lots of people ask me like, "Hey, should I even get into software anymore? Because AI is going to do it all." And I just kind of laugh. Like, it doesn't do it all. I mean, it's getting better, and it will get better, but it's going to make programmers faster. Non-programmers will still not be able to use this stuff. They're like all sorts of clickbait YouTube videos. Like, look, I built a mobile app only using ChatGPT, and I'm not a programmer. I don't know what I'm doing. And I built a mobile. Like, no, you didn't. You built garbage. You built hot garbage. Like, no one's going to use your mobile app because it sucks. So that sort of thing. I'm sorry, I got off track. Where were we? All right, we did 2 of the 3 things we're supposed to do today. What was the last one? Talk more about dictionaries?
Yeah.
Okay.
Only the last line.
Yeah.
So that doesn't on the chat really.
Yeah. Our Connect 4?
Well,
I think, did I start it here? I don't remember if I think I started it. Let's go see. My new computer puts everything in OneDrive, and I'm sad about it, but that's fine. Because Microsoft can keep 2 copies in the cloud if they want. Lab 4, right? We started it here. Oh, this was mostly a copy paste here, right? But we changed the board a little bit. So we looked at make a move. So this was just column number, right? So making sure the column was fine and then finding the first open spot based on a column. We said, okay, let's start at 5 and let's go all the way to 0, right? But we have to go 1 past when you range and we're going to go negative steps. So we count 5, 4, 3, 2, 1, right? You also, if you don't like doing this, you can just literally say like here's a list of 5, 4, 3, 2, 1, 0. Like that's perfectly fine. You don't have to come up with this range yourself. Like doing it the hard way is still okay. Right? That's perfectly fine. Like don't feel bad if you come up with this. That's okay. It does the same thing. Right? That's all. Okay. I'm gonna put my spaces. That bothers me. Okay. So if we find an open spot, mark the player and then break the loop. Stop the loop. So this will mark the topmost column or topmost row. If that one's not right. So we know at least that one is open because we made sure that it's open, right? Row 0 should be open. I'm sorry, row 5 is the bottom one. I'm sorry. I said top. The bottom. We start at the bottom. check the bottom row. If it's open, mark it. If the bottom's not open, check the next one. Eventually, we'll get to an open column, open row, because we know row 0 was open. Because you couldn't get out of this loop until this happened. So let's make our move. Printing the boards, printed ugly, but that's okay. Is the game over? Did someone win? Or so there's no cats game on this one. Let's just maybe draw. What we just say is tied, maybe. We'll just rename that. So is tied. So for is tied, if we find a space, it's not tied. If we don't find any spaces, yeah, it's tied. Right? Same idea with the cats game. Just look at every row. As soon as we find a space, we know the game's not tied. Right? Did someone win is a little trickier, right? We've got diagonal, we've got vertical, we got horizontal. Now, I liked breaking diagonal into diagonal up and diagonal down because that made a little more sense for me. You didn't have to, but you could. So we'll say diagonal up, and we'll do the same with diagonal down. Diagonal down. So this is up or diagonal down. Right? Any of those directions. So with the down loop now, we had a little bit different. In the up loop, we had a little bit different. So going diagonally up, we knew there were only 3 rows we had to look at, right? Because you had to have 4 rows worth in a row. So we started at row 5, at row 4, and at row 3, and then we looked up the next 3 rows, right? So we can go for row index in range. We want 3 to 6, right? Because that will be 3, 4, and 5 if you want. Or again, just give it a list 3, 4, 5. Perfectly fine. And then, so we want row 3, row 2, row 1, row 0, or row 4, row 3, row 2, row 1, or row 5, 5, 4, 3, 2. Because it has to be 4 rows. And I know there's only 6 rows total. So my indexes are 0 through 6, or 0 through 5. Right? So this is the bottom 3 rows, right? Bottom 3 rows. Now I'm going to check the first 4 columns because there's 7 columns total in the game. So I need to check column 0, column 1, column 2, column 3, because 3 is the first thing in it, because then I'll have 3, 4, 5, 6. Right? So for column index in range 0 through 4, because I want 0 through 3, right? This is the first 4 columns. Now I'm going to go diagonally up with this one, right? So diagonally up means minus a row plus a column. So first I want to check, hey, if my board at the row index, at the column index does not equal a space, right? It's not open, right? And then they all match. So if it's not a space and they match, X's or O's or white and black or green or yellow, whatever color is going to match here is fine. Here. So we can say if it's not a space, then, right? And this one matches the row -1, column +1, right? That's diagonally up one. And those ones here. Right? This gets a little long here, sorry. And slash. So, oh goodness gracious, why did it do that?
What is slash for?
The slash is telling Python, please go to the next line. Usually, as soon as you go down a line, it thinks you've finished your code. Right? So then we want -2 and +2. And, oh, it's trying to get down to the next one here. That's why. -3 and +3. So if that's true, then I return true. Someone won diagonally. If I loop through all the rows and all the columns, these 12 checks here, then I can return false because I didn't return a true. So if I found one that was not blank and they matched, why is it not like that? I don't know. Those yellow lines are PyCharm's being dumb today. Yeah. I'm sorry?
Oh, those are the bottom.
Yeah, so we're going -1 to go up a row, -2 to go up 2 rows, -3 to go up 3 rows. Because I'm starting at row 3 through 6, or 3 through 5. Row 3, row 4, row 5. Right? And then the first 4 columns, 0, 1, 2, and 3. The bottom 3 rows, right? That's 3, 4, and 5. Right? 0, 1, 2, and 3 for indexes. Right? Diagonally down is the exact same thing. but now I start with different rows, right? These now I want to start with 0 and go through 4. No, 3, 4, 5. No, 0 through 3 is 0, 1, and 2. 0, 1, and 2. And then I'm going to go +1 for row, +2 for row, +3 for row, because that goes down. When you increase the row index, you're going down in that 2 dimension, the second dimension. Right? The columns are still going to the right, right, by adding 1. Does that make sense for down? Right? Same idea. We're just going increasing the row index, and we're starting at the top instead of the bottom. So this is top 3. Right? Because as you increase your row count, you're moving down. So we're not math land with the origin in the center. We're computer land with the 0, 0 at the top left. Like pixel count. Like this is the 0, 0 pixel in the top left. Right? That's how we count things in computer land. Does that all make sense? And then for vertically, right? So for every column in range, well, I know there are 7 columns, right? So that's 0 through 6. If it's not a blank and it matches this one and this one, okay, well, I have to check now a bunch of different rows, right? So for every column, then I'm also going to check for every row. Um, for row index in range. So because there's 6 rows, right, I can do 0, 1, and 2 to increase to get 4 in a row, right? So range 3 is 0, 1, and 2, right? If the board at the row index uh, at the column, that should be column index. I'm feeling bad about that one. Let me rename. So refactor rename. Oops. Column index is not a blank, and the row index matches the column index, matches the row index +1. Oh, here we go. That's right. Equals the row index +2. We could do that shortcut. I forgot. It's 2 equals the row index +3. There we go. Right? So this will check starting at row 0, count 4 rows. Start at row 1, count 4 rows. Start at row 2, count 4 rows. Right? Because I've got multiple locations to check here for every column in the board. Right? This back up for 1. Right? And if we didn't return a true, we didn't find a matching vertical, we return false. Then for someone went horizontally, for every row on the board, now this I need to check for column. So this should be, so row is okay because row will give me a list, right? It's a list of lists. So row, it doesn't need to be row index if you don't want it to be. This gets a little funny. You're welcome to keep using row index, but this is fun. You don't have to in range. So now for columns, right, we can go up to 4, which will give me 0, 1, 2, and 3, right? Because I have 7 columns, so 3 is valid. So 3, 4, 5, 6 is a possible connection here. So row at column index is not blank, and row at column index equals row at column index +1 equals row at column index +2 equals row at index at column +3. Row at column index +3. Right. So that one they didn't. Do I need the slash? There we go. Oh, I did a for loop. Okay. So I had to tap it. It thinks this slash is unnecessary. Sometimes it doesn't need them, and I don't know why. It's like sometimes it figures it out. Right. So if we found a row here, this column, this column, this column, +1, column +2, column +3, we did it. Okay, so we can take these ones out, right? We can just say more doubles equals. Let's take those out. Equals. Let's put it up here so it lines up a little better. Okay, so uh, equals. Yeah, that's a little prettier. I like that. And that one equals that one, and equals that one, equals that one. Okay. All right, I was just trying to be consistent here. So that's it for Connect 4, right? So for board and range, right, add 6 rows. For every row, add 7 columns. Right, current player's X, as long as the game's not over, make a move. X turns to O turns to X. And print. Why is it doing this to me? Uh-oh. We broke it. List index out of range. Okay. Game over in board. Uh-oh. Use game over in board. That was Is game over board. Just on win horizontally. Row at column index. Uh-oh. List index out of bounds. Did I not set up the board? All right, I don't know. Let's put a breakpoint in. Let's see what happens. So here's my board. That should make the board when I'm done. So let's put it in debug mode. So my board. Oh, the first one's empty. Oh goodness. Okay. Yep, I made the board wrong. So I don't want to append a space. I need the board at the row, then append a space. Right? So I have a blank list and then I have 7 spaces. And I have a blank list and 7 spaces. And I have a blank list and I have 7 spaces. So I screwed that up. I didn't add the spaces to the row. Does that make sense? Okay. So we found out with debug mode, right? We found out what it was doing wrong. Let's give it a run. All right, there we go. So what column? You guys want to play? Third column. All right, so I'll go in the second column. Where are you going? Fourth column. All right, I'll go in the fifth column. Okay, I'll go in the second column. Okay, I'll go in the third column. Okay, I'll go in the second column. Okay, I'll go in column 1. All right, I win. Good try. I guess you have to go to lab. No A for you. All right. So that was the lab. That was Connect 4. Again, just trying to work with lists of lists. This two-dimensional idea is very common, having two-dimensional data. It's going to be, you'll never get rid of it. We love making tables of things, lists of lists, essentially. Uh, okay. All right. Awesome. The last thing then, and we were about out of time, was talking about dictionaries. I think we finished dictionaries, didn't we? Oh, we didn't do dictionary nesting. Oh, we did. We talked about dictionaries and dictionaries, right? The key of this, right? So just like we did a list at row, at column, it's dictionary key of this gives you another dictionary, so you do key of again. So students key of Jose, key of grade will give you the value associated with grade with the value associated with Jose, right? You get A plus. So we'll practice this in lab. We'll make a dictionary of dictionaries. Grade books are lots of fun. They're super exciting. Um, that's a lie. I'm sorry. They're awful, but that's okay. We'll practice. Um, this idea is a data structure. It's a way for us to organize data. Okay, we have lots of fun with it. So here's their grades dictionary of dictionary of look at this, a dictionary with a list associated with this one here. So dictionary of dictionaries, one of the values associated with the key in the inner dictionary is another list. But sure, we could do that, right? So we could work through and start adding values for things. Oh, that's right. We looked at Justin Bieber, right? He had all sorts of good songs. He's the platinum guy. He's producing another Trolls movie, right? Is that one? It's coming out soon. My girls love Trolls. My little guy loves Trolls too. He loves their songs. All right, we'll call it a day. We'll head over to the lab. Sounds good. Thanks, folks.